All right, in this video, I'll be going over page 13 and 14 from the notes packet. So this is on absolute value equations. So remember that an absolute value for a number is that number's distance from 0 on a number line. So whatever the number is, we're talking about how far is it from 0. So for any non-zero absolute value, there are exactly two numbers with that absolute value. As we can see with 5 here being our example. If we start at 5, we can either move 5 to the right and get to 5, or we can move 5 to the left and get to -5. So -5 and 5 both have an absolute value of 5, right? They're both 5 from 0. So in the example above, both 5 and -5 have an absolute value of 5. So for finding the absolute value of these numbers, well, -436 is 436 from 0, 712 is 712 from 0, 390 is 390 from 0, and -123 is 123 from 0. So all you do is you rewrite the number. If it's negative, you make it positive. So that leads us to something like this. An absolute value equation. So in this case, we have something inside the absolute value, and we're trying to solve for x. So the way we're going to do this, we're going to use our inverse operations to isolate the absolute value expression. So what that'll look like is we have this absolute value x plus 2 over here. We want to manipulate it so that we have nothing but the x plus 2 on this side. To do that, we're going to start by subtracting 4 on either side. That gives us 3 times the absolute value of x plus 2 is equal to 21. We can divide both sides by 3. We get the absolute value of x plus 2 is equal to 7. All right. Then we're going to split the resulting equation. We're going to write the resulting equation as two cases. So what are those two cases? Well, if the absolute value of x plus 2 is equal to 7, we know there are two options. X plus 2 could be equal to 7, or x plus 2 could be equal to -7. Because either way, if it comes out to 7 or if it comes out to -7, when we put it back in the absolute value, it's going to become 7. All right, and then we solve both cases, and that will give us two answers. So in this case, x plus 2 is equal to 7. We're going to subtract 2. We're going to get x is equal to 5. Over here, we're going to subtract 2. We're going to get x is equal to -9. So that means if x is 5 or if x is -9, x plus 2 is going to be equal to, the absolute value of x plus 2 is going to be equal to 7, which will solve this equation here. I'm just going to jump ahead to page 14. Let's do some practice here. So in problem 1, we want to divide both sides by 7 to isolate the absolute value. We're going to get the absolute value of n is equal to 8. And that means n could be 8. N could also be -8. Here, if we multiply both sides by 5, we get the absolute value of m is equal to 15, which means m could be 15, or m could also be -15. All right, over here, we want to, again, start by isolating our absolute value equations. I'm going to subtract 4 from both sides. Gives me the absolute value of 6x is equal to 24. That means that -6x could be equal to 24, or -6x could be equal to -24. I want to divide both sides by -6. That means x is equal to -4. Or if we divide by -6 over here, x is equal to +4. We want to be careful, though, because even though all of these answers have been positive, negative, that is not always the case. So if we look at this one over here, we have 2x plus 4. The absolute value of 2x plus 4 is 17, meaning that 2x plus 4 could either be +17 or 2x plus 4 could be -17. If it's positive 17, then we subtract over and we get 2x is equal to 13. It means that x is equal to 13 over 2. And over here, we're going to get 2x is equal to negative 21, meaning that x is equal to negative 21 over 2. Notice how this is not just the positive and negative of the same number. They're kind of different numbers. You could even have two positive numbers or two negative numbers, so just make sure you're following the process and not just assuming what the answer will be. And just as with solving regular equations, we have some special cases we want to be aware of. So if the absolute value in the expression equals 0, then there's only one equation or one solution. So let's look at example 1 over here. If we add 8 to both sides, we see that 0 is equal to the absolute value of a plus 2. Well, the absolute value of 0, the only place where that's true is 0. So here, 0 equals a plus 2, and your only answer is a is equal to negative 2. Right? So if the absolute value is equal to 0, you only have one solution, because 0, the only number with absolute value 0 is 0. The other special case is if the equation states that the absolute value is negative, there is no solutions. And remember, absolute value is always non-negative because it represents a distance. So absolute value is always positive, meaning that if we subtract 3 from both sides, get the absolute value of b plus 4 is equal to negative 3. Well, no matter what b is, no matter whether this is positive or negative, the absolute value is going to make it positive. So there's no way that's going to be equal to negative 3, meaning that this has to be no solutions. So if we look down here, let's try and identify these. We do not need to actually solve them because, well, if the absolute value is equal to 0, we know it is one solution. If the absolute value is equal to negative 1, then we know it is no solution. And if it's equal to a positive number, well, this is the case where we would have two solutions, right? This is the normal case over here. All right, that takes us to the end of page 14.